a panel discussion on incorporating simulation solutions for your product development at early in your development cycle. So for any of your product to be competitive, it's not just about aesthetics anymore. It has to be, it has to perform effectively and efficiently. And while incorporating these kind of simulation solutions early in your design cycle will help companies to reduce development costs and accelerate your product to the market. So with that being said, I'll straight away jump into the discussion. And before that, I would encourage you to ask questions. And at the same time, I would also request you to park your questions till the end of the session, right? And based on the, in the interest of time, you may take a couple of questions as well. So straight away, I'll jump straight into the questions. I'll have my first question to Mr. Manjunath. So we have experts here who are into mainstream engineering and development, and they have extensive knowledge on product development as well. So what do you think on how effective is integrated CAE with respect to productivity, time saving, and ease of use?
Okay, good afternoon all. Myself Manjunath, I'm working in Bharat Foods Warner Limited. I'm manager in R&D. Actually, I am using this CA tool from last 8 years. When I completed my master degree, immediately after that, I joined as CA engineer in BFW. So actually, this particular question, I will put based on my experience. Let's see, like in this particular room, whatever the environment we have, it's like, we can say it's a completely design knowledgeable group. So where they want to centralize design, simulation or analysis or this test into a single platform. So that particular solution, what we get from one of the CAE solution is SolidWorks Simulation. So where this is a single platform, which will help for us part of a productivity. If you see, productivity point of view, if you see, it's a single platform where we can design and we can simulate in the same platform. So if you want to, a particular parameter, if you want to change, let us consider parameter like length or thickness or material, if you want to change, and then you want to simulate, in the same single window, you can simulate it. So that's how we can even save that time. Look, time saving in terms of like, you need not to develop any physical prototype. Okay, directly what you can do, whatever the model you build through the CAD, the same model you can utilize it for the CAE solution. Like you can save a time by avoiding a physical prototype development. Okay, and there you can use even some physical variable boundary conditions virtual in a virtual environment, that is in a CAE environment. And when it comes to ease of use, so ease of use means, as I am telling, people who are exposure with the CAD, he can easily use this CA tool, that is SolidWorks Simulation. Like since it's a single window, you can utilize it very easily. It's a user friendly. And what I am talking about, the report generation, if you take, so it is very, very easy. So if you do it manually, there are a lot of chances like you can make a mistakes. But in this particular tool, in an integrated CAE, what it can help is like it can give a clear and concise report, which even it can give us some data visualization on the whatever the results you have, and even what it can do, it can justify whatever the results you get, and you have a even like a option of customizing it, whatever the way you can use, like you can customize it. So I mean, it is very much helpful for us, like as a integrated CAE for this knowledgeable group.
Thanks, Manjunath. So, since we've been talking about simulation solutions, ModSim. So it's the ModSim concept, the ModSim modeling and simulation concept is nothing new to SolidWorks ecosystem or SolidWorks community. So we have SolidWorks structural simulations, flow simulations, and plastics that is embedded into a CAD. So that is what Mr. Manjunath was referring to, and he was also highlighting the benefits of using that CAD integrated simulation approach or simulation driven design. Thanks, Manjunath. So my next question would be to Mr. Subrato. So for any product during in its product life cycle journey, how do you decide when and where to use simulation in product development?
Yeah, so good afternoon, everyone. This is Subrata Patra, Principal Consultant with SAT Technic Solutions. So it's a very important question, right? When and where to use the simulation tools. I would say as early as possible in your design cycle. So there are two kind of things, right? One is sort of ground up design. You are starting from the scratch, and another would be like you are doing re-engineering, right? So the value, the maximum value that you can get out of this simulation tool is when you do the ground up design, right? You don't have anything, you have a concept, you want to build something and then sort of, get it to the market. That's the place where you want to sort of use, various kinds of, simulation tools, including what we have seen today. Um, I think we have already spoken about few things, few advantages. Faster time to market. You don't have to sort of build a prototype, so you can potentially save a lot of costs, right? I would sort of add a couple of more things to it, from our experience as a service company. One would be, I would say, in cases where you can't really test, right? For example, think about the satellite simulation. The satellite is going to sort of, go around the Earth and going to stay there for many years, probably a decade or so. You cannot test it, can you? You cannot send the satellite and test it and bring it back and then again sort of make the changes and sort of as per your simulation results and then send it back into the orbit. You can't do that. So you have to have your robust simulation system in place to sort of test it virtually using the simulation tool and make sure everything is tied up there so that you could sort of confidently send it to the orbit, right? So that's one, I would say. It's a probably extreme case, but it's a good example, where to start and when to start. The second would be, at SciTechnique, Technique, we use a lot of advanced simulation capability. For example, AI. I think everybody is aware of AI these days, particularly the generative AI, GNAI we call it fondly. So we have some capability, some tool where we sort of integrate GNAI into the simulation tool to optimize certain factors, for example, the design for manufacturing, DFM, which you cannot otherwise do. So using Gen AI, which human ability or human brain cannot think of, so AI can think of, and it also configures the manufacturability already built into it. So think about it like two layers. One is, of course, the software that you're using, and you get some output. And using those output, you sort of take those outputs into the Gen AI tool, advanced tool, and then get it optimized. Having the design for manufacturing already built into it. So that's an amazing thing, and you don't have to really go send it to the manufacturer and get it tested whether it's manufactured. It may be a best thing for you, right? But if it cannot be manufactured, it's of no use. So if the tool itself can sort of factor that in for you multiple times every time, that's the awesome thing, I would say. So these are the two examples I just wanted to give you to think through. Two extreme. One is the space application, another is the GNAI. So these are the two high-end things that we are sort of doing for our customers at SciTechnic Technic Solutions. Thank you so much.
Thank you, thanks. So that's a different perspective of testing your satellite. So you can't simulate or you can't set up that space environment on the ground, no matter how much sophisticated your laboratory is, right? So the only way to test that would be in a virtual environment, in a simulation software where you can create that kind of scenarios. And also appreciate that you touched upon MI and AI learning. So whatever the data we have had in our past, and using that data to predict what is going to be the behavior of my product. So thanks for that. So now I would like to move on to Mr. Jagdish, and from you I would like to understand how do you define the role of simulation in your product development for your organization.
Okay. Good afternoon to all. Ellargu namaskara. Myself Jagdish. I joined in Bell in 2007 after my masters. So I think most of you are aware Bharat Electronics Limited is working under Ministry of Defense. We do develop the defense electronic products majorly and some non-defense products. When it comes to defense electronic products, we are there in different areas, starting from missile systems, military radars, electronic warfare, and many more. Being, defense products, it has to work in a harsh environment. It will be like negative temperatures from -30 to -40, as well as a higher level up to 71 in case of airborne and land-based 55 degrees. So in order to meet, as well as other important thing is we have to qualify for a lot of standards, mill standards, which is environmental as well as EMAMC standards. Without that, product cannot be inducted. To meet all this, the simulations play very, very major role. In our process design verification, which is a simulation which is very much part of the process, we do a lot of different simulations, structural, thermal, as well as electromagnetic simulations, starting from the PCB level, chassis level, system level, so that it can meet the requirements. And as everybody is telling, the one is time to market, because now we are in the competitive environment, whether it is from inside country as well as outside the country. So the time to market is very important. The design cycle time should be very, very short. Otherwise, it is very difficult to meet the timelines in this competitive market. So this is another factor which is where simulation will play a very major role. And the last part is that reliability of the products is very, very important. Our defense products, it has to be, life is very, very high, more than 10, 15 years. It has to work in the field. So in order to meet that, basically if you take a design thumb rule, every 10 degrees of temperature reduction will improve the life, double. So with that, the simulations early in the design process, so that it will play a major role. This is how entire Bharat Electronics product process will go.
Thank you, sir. So thank you for touching upon the very important point on the reliability or the durability of your product for defense applications. So I'll move back to Mr. Manjunath, and my question to be is, what are the what are the challenges that companies face while implementing simulation solutions? So traditionally, it's all CAD-based solutions or CAD-based organizations. So what potential challenges you might have faced, and how is that you have overcome those challenges?
Yeah, it's a good question for me because see, as I told, BFW is a 6-decade-old company. Okay, it's a 62-year-old company where I can see people with a 35 years experience. They are all working there. And when I entered BFW in there 2016, I mean, I was very fresher there. So major thing what I faced there is like when I entered as a CA engineer, like see they not allowed me. Not the whatever the workflow, whatever the system we were having, it is not allowed me to interrupt any workflow currently, because see whatever the timeline for the manufacturing we will be having, it is already based on the whatever they have made for the last 6 years. It is there. So, but as a CA engineer, like what his capability is, like he want to come up with a new methodology, like whatever the currently we are following the traditional design methodology, and but what I am bringing, like we want to bring a new CA based methodology. So there, like one thing, major thing is a cultural shift. So cultural shift is the major challenge there, like because introducing a CA into the existing work platform. So that is a major shift. Like, and second thing, when it is new to the environment, again there is a like a computational resource requirement. Again, the skill development is required. And next thing, like people won't believe as it is. Like they think about the data accuracy and the reliability on the data. And not only that, they would also think about the return on investment, because it's not a one-time investment, I agree, but cost-wise it is higher side, right? So in that case, what benefit we get once we invest on it? So these are the major challenges. And how we can overcome these things? Like skill development means like we need to keep training the CA engineers or the whoever the even like it is much easier. CA is a much easier and useful. Like when they go for the SolidWorks simulation, it is easier because environment itself is like that. Or whoever use the CAD, he can even directly shift to the CA because it's a single window. So whenever required, if you train them, he will get a skill. And when I am talking about the computational resources, we are having a recent, so far from morning we are hearing that cloud computing. So what systems we are using, even most of the industries we use 8 core, max to max 16 cores. But what about the cloud computing? We can use up to 144 cores. See, we analyze our, like, we are from the machine tool background. So CNC machines and all, we analyze it for the static, dynamic, thermal, flow analysis. If you take a complete machine flow analysis or a thermal analysis, it consumes more space. Even I personally, I mean, I'm using 128 GB RAM there, but with a 16 core, I myself take almost 48 hours to compute the one particular machine assembly. So that's how, like, if I use cloud computing, it will solve in a quick enough time. Okay. And next thing, what I was telling about the accuracy, data accuracy, and the reliability, how we can make our, what I'm telling about the traditional design approach guys, how I can make them to believe it. So we have to like spend our more time on validating the whatever the simulated results. We have to validate, we have to get our confidence in it. Okay, that's how we can make our guys to believe these CA results are, we can believe it, we can save time in it. So that's how. And what I was telling about the ROI, that's return on investment. So that is how, if we tackle few design issues, whatever in an initial stage, if we open our management eyes, so that's how we can get a return on investment.
So thanks, Manjana. So what essentially he said is, in a traditional way, we have CAD design and manufacturing. So when you're adding another component there, CAD design and simulation, and then manufacturing, so it leads to whole set of different challenges. And Mr. Manjunath himself has underwent through that challenges in his organization. So thanks you for shedding, enlightening us on how do we overcome that. So next, my question would be to, will be to Mrs. Subrato. So in your experience for organizations that are just beginning with early simulation, so what are some practical first steps or best practices to ease this transition from CAD-driven to CAD and simulation-driven design?
So for, I think, the maximum benefit that you get, right, out of a simulation tool is by a small team, the first-time users, right? So I would say you sort of go to an authorized reseller, and then sort of articulate your requirement, what are the things that you are going to do, and then have a trial version first sort of roll out for you, right? And then, try it out, give it to your bunch of engineers and ask them to sort of test it for 10 days to, 2 weeks or so, and come back to the authorized reseller and say, hey, these are the problems, or these are the things, can you customize, and we really want to use it. And this is, even more important when you have sort of, team, geographically diverse or working from home. I think that's the reality, we like it or not. Some people are sort of working from home, some are coming to office. So how do you collaborate virtually? I think having a simulation tool is very important. So take a baby step, approach a reseller, and then ask them, and then do some kind of A/B testing, what I call it, right? Simple testing. Keep some kind of parametric study in place, and also start building some scenarios, right, for your customers. This is scenario 1, scenario 2, scenario 3, scenario 4, and let your customers sort of evaluate, those kind of scenarios and what kind of works best for them, and then have them, come back to you and you give a quotation, those kind of things, I would say. And these are very easy steps, using a simulation tool. You cannot really go for testing. That's virtually impossible.
Right. So, in the earlier discussions, so Manjunath expressed his, his thoughts on implementing the simulation itself. But Mr. Subrato gave us, a different perspective on what would be the challenges when, even though companies have decided to go with a simulation. So, performing a simulation, complex simulation, it's not just, taking your CAD model and submitting it to run. So you need someone to hold you in your initial phase. So that transition or that initial phase, you need someone to help you with, incorporating this simulation for your product development or starting your simulation journey. So with this, I would like to move on to my next questions to Mr. Jagdish. So what are the key simulation studies that you perform using SOLIDWORKS simulation and flow simulations, for your in your organization?
Yeah, as I told you, we are into defense electronics development. As you all are aware, the technology advancements are very, very fast. The processing requirements also very high nowadays within a small area. So a lot of heat gets generated from these devices, which needs to be controlled to meet very challenging environments. As I told, sometimes it is 71 degrees ambient requirements. So when we that is very much regular process for us. The simulation is like CFD, whether it's a thermal, whether it is a flow. We have to do that so that the product will able to meet the requirement. That is about thermal part, where we will do a lot of things like we will try to see that whether we can cool it using natural convection, or we require a forced cooling, sometimes liquid cooling. So that is, those are the thermal part. The second part is a structural related. So the rugged environment requirements are vibrational requirements, because all these products will be kept in a such a places where it will be prone to a lot of vibrations as well as shock and bump. So we do vibration analysis. In that process, we will do initially the model analysis to find out the natural frequencies. Then we do harmonic analysis to see the structural integrity of the parts, so that it can meet different random vibration as well as sinusoidal vibration, shock, bump requirement. Apart from this, our other stakeholders who does this electromagnetic simulations.
So thank you thank you for giving us the real life, real world examples of using SolidWorks suite of simulation solutions for your applications. So my next questions to Mr. Manjunath, and this is from my personal experience that he is using SolidWorks simulation, structural simulation, and on a daily basis though. So what is your experience with respect to the usage of SolidWorks simulation and with respect to the learning experience of using SolidWorks structural simulation? That is our SolidWorks simulation tool.
As I said, I am from machine tool background. Like, see, any of our structures, if you take, they behave like a beam only. Okay, one behave like a cantilever beam, one behave like a fixed beam. So, see, as a beginner level, as a initial step to the introduction to the CAE, what I have done. So I have started with a simple beam, like only static analysis kind of thing. So even like whoever in this room, like a student, maybe a student or a fresher to the industry, I urge them to not to, they stick to the only design point of view, design engineer. They should even learn simulation. So that's how they are bringing the concept of mod sim, modeling and simulation together as mod sim engineer. So, so what I want to tell is like I have started my experience like initially as a beginner level, started with the static analysis. So in that case, like even especially conceptual team, they have helped us, like they have provided the hands-on experience with the tool, and even they have provided some tutorials. Even for you guys, you will get a n number of videos in the YouTube platform and all those things, and you can attend a webinars and some of the seminars, and all these things are there for the beginner level. And if I want to talk to next level, if you want to move, that we call it the intermediate level or the mid CAE level. What we can do there, we can look for not only just stick to the static, you can just go to the next step, like a frequency analysis, fatigue analysis, thermal analysis, where you need some fundamental, like what I can say, simulation principles, where you need to learn those things. So then if you learn all those things, you can just get through this maybe fatigue analysis for the life calculation, and thermal analysis, how the heat transfer occurs in the structures, and frequency, like these are frequency, what I'm talking about, the natural frequency, it's a dynamic parameter of any structure. To do that, to get to know and to justify the results, you should know the fundamental principles of the simulation. And to become a what I can say, like advanced proficiency, so whom we call advanced proficiency CAE, people who do this CFD, flow analysis, so who work on this aerodynamics, and even in our applications we use for spindles, what we call the machine heart, that is a spindle. So there we use some cooling jackets and all. So how this coolant flows into that, so that we want to simulate how this cooling efficiency we can improve. So to do that, again, we need not only just simulation principles, we should also know fundamentals or the whatever the advanced level of the concepts, what we are doing, what exactly we are designing. So those things we should know. And fourth stage, what I can say, we should also learn through our projects. Like while doing the project, we can, whatever the application we are working, so in that case, we can approach the our product provider, like maybe a conceptia, we can approach them. They will help us in dealing with what exactly the assignment we are going through. So that's how we can learn this particular CA.
Thanks, Manjunath, on highlighting the the ease of use as my next question to Mrs. Subrato. So compared to the past, with not having integrated simulation and to having access to simulation at early stages of product design, what are the potential savings with respect to project deadlines, reworks, material cost, or overall product development for an organization?
So I'll be short and sweet because I know time is running up. So as sort of complexities increase, right? As you sort of discover more complexities in product development, I think this integrated approach is very important. For example, the structural, thermal, and EMI, EMC sort of coexist, right? You cannot sort of develop a product without having overlooked thermal or EMI, EMC. So most of the PCB boards will have thermal challenges as well as EMI, EMC challenges. Even if I take one piece, right, for example, thermal, you will have a granular approach. You need to have a granular approach. For example, you do a traditional simulation, right, using the thermal interface material or different other things. And you also need to do an advanced kind of simulation. For example, two-phase vapor compression, which we do at SIAD Technique, often for our customers. So given the complexity, high heat density, for example, staying with thermal for now, you need to do this kind of, traditional as well as advanced capability in place. So I see, having a platform approach, an integrated approach kind of saves you time. And you don't have to sort of go to other players, different players, for different kind of requirements. Because if you just satisfy thermal and don't satisfy EMI, EMC, it doesn't work for you. You cannot still, take the product to market because you need to have an EMI, EMC certificate in place.
So yeah, that's one of the key benefit of having either embedded simulation solutions or integrated simulation solutions with your CAD. So this is going to be my final question to Mr. Jagdish. So in your organization, right? So you come up with different ideas and concepts. So do you think that simulation will make it easier to test different ideas, and if it is, how so?
Yeah, that is absolutely sure, because I will tell with an example. Recently, we got a requirement from for a certain product, which is a computing product for a fighter aircraft. As an airborne system, it will have dimensional challenges as well as weight challenges. So when the project has come, when we are discussing, at the architectural level, so this obviously the electronics generates that heat which has to be dissipated, and now what are the different ideas we can use it to meet the dimensional requirement. And during that, simulations help us to tell about other stakeholders who are electronics partners, so that lot of negotiations will happen, because final requirement is we cannot sacrifice the dimensions and weight. So during that process, we will try with different ideas, different concepts, different thermal management techniques, and weight reduction without compromising the structural integrity. So all this will be done at a very, very initial stage, so that we will able to meet the final requirement. That is how simulation will definitely help us to try all our innovative ideas initial stage.
So I thank you all, for giving their valuable insights on the real world challenges that you might face, either while doing simulation or either while incorporating simulation solutions or starting your simulation journey. Thanks again for our panelists, Mr. Manjunath, Mr. Subrato, and Mr. Jagdish, who enlightened us with their vast experience on simulation-driven design. Thank you. Thanks a lot.
Thank you so much. It was really, really wonderful.
Please,
I would request the panelists to please hold on for a minute. I would like to call upon Mr. Divakar from Dassaults to please come on stage, along with Mr. Arun Stevenson. Let's put our hands together, everybody. So now we're going to hand over the memento as a token of appreciation for our panelists. And quickly after that, we're going to have a picture clicked with the panelists. Thank you so much. It was such an interesting session and it was very, very interactive. Thank you